Hi class, this is Professor Teixeira. In this video, I'm going to talk about CPK, the second measure of process capability. Remember, this CPK measure is designed um, to provide information about the capability of a process if the process may not be centered. Going back to a machine example, let's assume the machine is filling bottles of water, but not on average with 16 ounces, as was designed to do it, is now filling bottles of water with 15.9 on average. So the center of the distribution of the bottles of water is now, let's say, off the center. Here's one example. I want to remind you about this, what the example is. We have a company filling bottles of, I don't know, water. Let's assume it's water. I don't remember what it is. 3 bottling machines are being used for possible use at the fish plant. The machines must be capable of meeting the design specification. What is the design specification? Minimum of 15.8 ounces and a maximum of 16.2 ounces with an average of 16 ounces. Okay, we worked in the previous video in the CP measure. Now we're going to use this, not entirely the same example, but the company to talk about CPK. This chart shows that now the center of the distribution, you see that this is a normal distribution. The center of distribution is not 16 ounces, it's 15.9. So the machine is filling the bottles with, on average, 15.9 ounces. So it's like there is like a let's say off balance. So it's off center, and that's what CPK is designed to measure. Okay. So when these situations happen, the CPK is a very good measure. You see that because the mean is off center, it was supposed to be here, the lower specification limits are like not capturing anymore, or the machines or the distribution of bottles filled are not using this correct specification anymore. Okay, so let's take a look here. Design specification for a target value of a mean of 16 ounces plus and minus 0.2 ounces, which gives our specification limits. However, like I showed here, the mean for this machine is 15.9 with a standard deviation of 0.1 ounce. We're gonna use these formulas here. Let me go back some slides. This is the formula for CPK. This formula, this is what this is saying is, I want the minimum between two values. This is the first value, this is the second value, and I want the minimum of these two as my final answer. So what we're gonna do today is compute in Excel this value. We're gonna compute in Excel this value, and then we're gonna enter a formula in Excel. So Excel brings us or tell us which one of the two is the smallest, and that's our CPK, our measure. Okay, so let's do it. And this is the application, but I want to show in Excel. You see that there are two numbers here. Let's see in Excel. So the information we have, I just enter here. First, the piece of information we have. So the upper specification limit is 16.2 ounces. The lower specification limit is 15.8 ounces. The mean for this machine is 15.9 ounces, and the standard deviation is 0.1. So these are the pieces of information we need. So first we need to make the difference between the pre-specification limit and the mean. So I enter equal pre-specification limit minus the mean. Then I have to compute the mean minus the lower specification limit. So equal mean minus the lower specification limit. Okay. And then I have to compute 3 sigma. Let's look at the formula. The formula here is dividing by 3 sigma. Now, why 3 sigma? Because we have two extremes and the center. So if we join all them, it's 6 sigma. Okay, then each of the half has 3 sigma. That's the reason we have now to divide by 3 sigma. Let's go back. So we do 3 times sigma. All right, now what we have to do is my CPK is gonna be equal, and I type equal, and then the function I want the minimum of some numbers. Oops, I want the minimum of some numbers. Which numbers are those? The first number here, Excel is highlighting the first number. The first number is my upper specification limit divided by my sigma. My second number is my mean, the difference between the mean and the lower specification limit divided by 3 sigma. And I want Excel to bring the smallest, the lowest of these two numbers, which is 0.33. Okay, so if you go back here, let's go back to the slide. We have a little bit difference because here this slide I think is wrong because it's using 0.67 as sigma, and here is saying that the sigma is 0.1. So we catch a mistake here. But anyhow, that's what the correct is. So if I change this just to make equal to the slides, if it is 0.67, right? 0.67, 0.067, then I'm gonna get the same number we have on the slides, which is 0.44, 0.4945 here. Yeah, there is some like difference probably because of the decimals. Okay, so let's see if I use 66667, then would be close to 0.5. But anyhow, that's how we compute the CPK. Okay, and that's it.